Hello, I'm Martin Sheen. You know, it's been 40 years since some concerned scientists started talking about environmental threats to our planet. Unfortunately, a number of those predictions are now becoming realities. The lack of fresh water in the normally arid parts of the world are now causing devastating famines as the world's 6 billion people stretch the Earth's capabilities. But some of the people who talked about these environmental threats are doing something about them. And I'd like you to see what they've done in the small East African nation of Eritrea, using pure seawater to grow food for people and animals, and through that effort put hundreds of developing world citizens to work. As you watch this incredible story unfold, just imagine it happening in thousands of other places, from the Red Sea to other coasts of Africa, to India and Asia, to Mexico, where it's already begun, and on to South America, a project for the whole world.
Right now, millions of people are not having access to enough food. Every day, each person needs about 2,100 kilocalories, and they're not getting anywhere close to that. People say every 4 or 5 years there's going to be another serious drought. It's how Eritrea is able to handle the drought and respond to it that's going to matter.
It is a mere dot, a blur on a spinning globe. A drought-ridden North African country, only slightly larger than the state of Pennsylvania, its coastline lying parched against the Red Sea.
Are the origin of human being. From these places, from these coasts, humanity emigrated all over the world. Everybody has his roots in this place.
Although its roots are ancient, Eritrea is the youngest nation on the African continent. Revolution has marred its history. A long, bitter war for independence has scarred its landscape. But there is a new revolution underway, one that has nothing to do with guns and tanks. It is a surging revolution, aimed at claiming freedom from the relentless drought that drains the nation's resources and saps the energy of its people.
Hello there. How are you? All these beautiful young children depend on goat milk, camel milk, and they normally depend on a little bit of grain. They grow maize, corn, and another year you could see it growing here. This year, zero, nada, because of no rain.
It is here on the Red Sea near the port city of Massawa that the war against drought is taking root. This new revolution has replaced guns and tanks with technology and human resolve. Seawater Farms Eritrea and the Desert Development Foundation have joined together with international investors and the government of Eritrea to establish the world's first commercial seawater farm. It has created jobs for over 400 Eritreans and also serves as a laboratory for marine biology students from the University of Asmara.
It's been tough at times.
Carl Hodges is the founding director. An atmospheric physicist and former director of the Environmental Research Lab at the University of Arizona, Hodges believes that growing seawater-loving plants in desert areas could have a profound effect on Eritrea's future.
This technology, seawater agriculture, when it's finally in all of its glory with maybe 20 or 30 agronomic crops, with a whole spectrum of aquatic animals, will eliminate the possibility of famine in Eritrea forever. It will be gone. And in fact, it will make Eritrea an exporter of food. So it has tremendous potential.
The benefits are threefold. Exporting seafood brings dollars into Eritrea's economy and provides employment for its people. The principal field crops of salicornia and mangrove have many uses, including much-needed ruminant feed for the country's livestock. And the greening of any portion of the Earth's surface reduces global warming, believed by many to be a contributing factor to global drought. The Seawater farm was begun in 1998 with the dredging of a channel that allowed water to flow from the Red Sea, a saltwater river flowing upstream into the desert.
Freshwater agriculture was invented about 10,000 years ago. It means we could stay home and somebody else would grow our food. All of our culture's built on it. But now we've run out of fresh water. This is seawater. This is a river of seawater coming inland.
The newly created 3-mile-long river meanders purposely through Seawater farms, first filling large tanks that anchor the farm shrimp operation. The water continues its route to enrich commercial fish ponds. Then, twice enhanced with nutrients from the shrimp and fish effluent, the river flows on to irrigate and fertilize agricultural crops. Eventually, many weeks or months later, having been biologically cleaned as it is filtered through the ground, the water makes its way back to the Red Sea.
The goal of this shrimp farm is to produce an export crop for Eritrea so that they can sell this and bring foreign currency in. And at the time we're selling our shrimp in Europe, they've been sold in Paris and London, and we try to keep our cropping plans flexible so that we can provide different sizes of shrimp. This farm is a completely closed cycle in the sense that all the effluent from these shrimp ponds goes on to Salicornia farm and eventually to the wetlands and salt production. None of it ever goes back to the ocean. And as far as I know, it's the first farm that's ever been built like that and that addresses the contamination and pollution issue so successfully.
Ponds of tilapia, a food fish being raised for the marketplace, are fertilized with water from the shrimp operation. Later, the enriched pond water is siphoned off to irrigate fields of salicornia. Salicornia is a halophyte, one of a family of plants that grows in pure, untreated seawater.
This is a commercial scale farm right here, this Salicornia field. Salicornia is exciting because you have the green plant. When it's young, you can eat it like a vegetable. When you harvest the seed, which is about 20% of the total biomass, of that seed, 30% is a high-quality vegetable oil, like safflower oil, for cooking or salad dressing. And the meal, the 70% that's left behind, is as good as soybean meal. It's high protein. You can use it as a supplement to human food. You can use it in animal diets. It's truly an exciting plant.
Salicornia also has commercial value in the strong composition building material that can be made from its dried husks.
The concept is to cover every square inch of land, so we're maximizing the benefit of solar energy here. The input energy is representing money. In addition to being used for fodder, this ornamental halophyte is also used for cooling the climate in the local area. This ground cover is also very helpful in stabilizing the soil against wind erosion.
This plant, if I don't break it off, has something underground that is critically important. Let me rinse it off. This sand that plant was growing in has essentially no carbon. This root structure is a carbohydrate. Good agricultural soil, which this will become over many, many years, has 16 to 18% carbon. So what we've done is we've taken fossil fuel, oil from plants millions of years ago, put it into the air as carbon dioxide. Made our life good by using energy. We're now, with intelligence, taking it back out, generating wealth. This is wealth, above ground wealth, and we're creating high carbon level soil for future generations. This is the way to solve global warming. If there's one area on the farm I hope everybody understands, it's this. This is seawater forestry farming. It is not forestry in the classical sense. These are mangrove trees that are 2 years old. They were seeds 2 years ago. When we planted them, 25 per square meter, we planted them this far apart. Then, when they were 1 year in, we cut every other tree. When we did that, we got an incredible yield. We got 10.6 metric tons of stems per hectare per year. Probably more importantly, we got 18 metric tons of leaves for animal feed, dry weight of leaves. And we left 35 tons of roots per hectare stored in the soil. These are the roots of the mangroves. It makes roots and sticks them up so that even when this is being irrigated, it can breathe oxygen. This was the diameter of a mangrove tree 1 year old. Here's one 2 years old. You can see the incredible growth. With this part missing, that's what a mangrove seed looks. It falls, the roots start out, find the ground, it turns up, and in 2 years, that'll be a tree this big. As the trees get bigger, they're building material.
And as the forests increase in density, they will provide firewood. Already a commercial honey crop is being harvested. Flamingos, herons, and more than 200 other species of birds have already found refuge in the fledgling forest. The mangrove industry has also offered a haven for a cooperative of women who have become the guardians of the forest. They pick and sell the mangrove leaves that are used as a component for animal feed.
So this is like the pilot group. It's 27 widows, mostly, not all of them. But the idea is to have a program where they can have education. But the main thing is to achieve that these women become self-sufficient from the forestry. So these women are experts on mangroves. They know how to grow it, take care of them, the seeds, the times, everything. They can teach you whatever you want to know about mangroves.
The number, thousands.
Literacy here in Eritrea is very, very, very low. I don't know exactly, but I don't think none of the women knew how to write and read before coming here. And now, mostly all of them know how to do that.
One of the greatest potentials here in Eritrea is livestock production. Obviously, in a place like this that's drought-prone, you can't really talk about growing large amounts of wheat and large amounts of cereals here. So we have to look at livestock. If we can develop this halophyte-based small ruminant feed, and we can grow animals here and we can feed them on basically seaweed, mangroves, that kind of thing, then that idea can be replicated up and down the Red Sea coast. Why couldn't we do it in any place along any coastline where seawater plants grow and there's a need for economic development, which describes a tremendous part of the world?
The Eritrean coastal area is the origin of human being. Human beings have their roots here, and I would like to see everybody coming here to see his roots. People from all over the world, the humanity.
You know, it's also the roots of the second agricultural revolution. It started 10,000 years ago, because now we're using seawater.
We're battling against human ignorance. We're battling against human greed. People that look at the developing world as a place to make money exclusively, not putting it in a broad enough context. We're battling against time. Basically, what we're doing is we're taking human intelligence, photosynthesis, putting them together correctly. When human intelligence built those tanks, the whole agenda of war was not the best use of human intelligence. If you're defending yourself, if you're fighting for independence, yes. Once you've got it, a much better use is to let all these remnants that you see around here, tanks laying in seawater, that will dissolve over the next 25 years. And those iron molecules will be in those mangrove trees. That's a much better use. of human intelligence. And it's a much more thrilling and rewarding war to fight.
Cycles of drought will continue in Eritrea, for drought is no stranger to the Horn of Africa. The seawater revolution that is greening the desert at Massawa could well be a matter of survival for this young nation. Yet, among some, there is an even greater vision stirring. There are 25,000 miles of coastal deserts around the world. The ultimate goal lies further than the eye can see and the oceans flow.
Just imagine converting much of the 25,000 miles of desert coastlines around the world to lush, productive green fields that feed millions. Imagine doing it in an environmentally enhancing way that absorbs enough carbon from the atmosphere to reverse global warming. And doing it all using the unlimited seawater and sunlight that surrounds our planet. What an amazing opportunity for our future. If you'd like to join me and find out what you can do to help make this vision a reality, visit our website at seawaterforest.org.